Hi, good day everyone. Welcome to the part 2 video presentation about the data and process modeling. So in our last video, we were left with this topic about the basic symbols of data flow diagram, and we have mentioned that there are two common sets of symbols that are used in developing a DFD. One is the Gain and Sarson symbols, and the other one is the Jordan symbols. So both, whatever or whichever set you're going to apply, it would mean the same process, it would mean the same data flow, it would mean the same data store, and it would mean the same external entity. So the symbol used for process with Gain and Sarson is actually a rectangle with rounded corners, while for Jordan, it's represented with a circle. For the data flow, they both use the same arrows. Okay, it can be arrow up, arrow down, arrow left, arrow right, because it represents data flow. Then we have the data store. For Gain and Sarson, we have an open-ended rectangle, while for Jordan, there's two parallel lines. Now, for the external entity, for Gain and Sarson, we have a double square, while for Jordan symbol, we have only square. So let's begin understanding and familiarizing each of these symbols. So external entity, what does it mean? Okay, you use external entity when you are going to represent an origin and or source of data. So it can be a person, it can be a group, it can be a department, it can be a machine or any system that either receives or originates or the source of information or data. So when the external entity is the origin, is where the data comes from, that external entity is called the source. While if the external entity receives it, then you call it as a sink. So external entity basically sends data to or receive data from the system. Now how we named it? Now we have to name it with a noun because it represents any of this. So in DFD, it can be used more than once. So it means that you can repeat using this symbol with the same name to avoid crossing data flow lines. The next symbol is the process symbol. So process symbol represents actions performed on data. So they are transformed, stored, or distributed. So process receives input data and produces output that has different content or both. Actually, process is referred to as a black box because you will know its input and output, but you don't know about its details or its logic, okay, because it's hidden. Not unless you're going to create the next level of DFD. So you can use either a rectangle with rounded corners or the circle. So any of these would mean an action or group of actions that takes place. So an example, okay, create student record. So create is actually an action. So when modeling the data processing of a system, it doesn't matter whether a process is performed manually or by a computer, because as what we have discussed, the logical DFD is basically focused on the actual business event or actual business process. So when naming a process, a clear name makes it easier to understand what the process is completing. So for context diagram or level 0, if you remember, I have mentioned about the 3 levels of DFD. So naming the name of each process in every level is different. So for level 0, you will assign the name of the whole system when naming a high-level process. So example, student management system, payroll system, billing system, or it can be a major subsystem, okay, like student registration subsystem, attendance subsystem. This will be the expected names when you name a level 0 process. Second, okay, for diagram 0 or level 1, or if you have the child diagram or level 2, we consider this level as detailed processes. So here we have to be specific on what kind or what is actually happening really in that process. So we will be using a verb, adjective, noun format. So example, register student timetable, compute student mark. Okay, so in this case, register is the verb. Okay, what to register? The timetable, but whose timetable? It's for the student. So what about compute student mark? Compute is the verb, mark is the noun, but what or whose mark? Okay, it is for the student's mark. Now, if it is clear, okay, what is the process all about, then it would be more clearer what would be the required input to that process and what would be the expected output. Now, we have to indicate a unique identifying number indicating its level within the diagram. So, process must not be repeated. So, that unique identifier, okay, which is in number, will indicate what process and what level is that of a DFD. The third symbol is the data store symbol. The data store is representing data at rest. It may represent one of the many different physical locations for data. So if you are talking about manual store, you can name it like a file folder or a filing cabinet or notebook. But if you are talking about a computerized storage, you can put exactly the computerized file or the database. So this data store is used in the FD to represent that data in the system stores because one or more processes needed to use that data at a later time. So it's simply showing a depository for data, which can also allow adding and opening or retrieval of data. Now, these two should be named as a noun because it's the name of a storage or data store. The fourth one, the last one, is the data flow. Data flow shows that information is being passed from or to a process. So, it will be representing an arrow with the head of the arrow pointing towards the data's destination. So, here we have to name it as a noun since it represents data about a person, a place, or a thing. Data flow occurs at the same time, are represented through the use of parallel arrows. So, for example, in a certain process, there can be two or more than two inputs or more than two outputs are expected in that particular process. So, you can use two parallel arrows. But more than one data flow noun phrase can appear also on a single arrow as long as all the flows on the same arrow move together as one package. So you will know later how to apply this one. So a data flow cannot go directly back to the same process it leaves. So for example, in that particular process, it produces an output. That output cannot directly go back to that process as input. A data flow to a data store. Okay, if the arrowhead is pointing to a data store, it means update. So it's either you are deleting, you are changing, or you are saving. But if a data flow, the arrowhead is from a data store, then it means that you are trying to retrieve or use a certain information. There are three levels of data flow diagram which I have mentioned to you. So this time, since you know already about the 4 basic symbols to use and its rules on how to use each symbol, so let us now learn what is this level 0, level 1, or level 2. Level 0, or what we call as context diagram, provides the most general view of an information system. So it's like giving a bird's eye view of what the information system all about. Now, you are expected to put only one single process symbol in level 0, which represents the whole system. Then you have to put all the entities, you have to put all the data flow, all inputs, all outputs, but there is no data store in level 0. So it is clear 3 symbols only should be evident in level 0, but there should be no data store. Okay, because data stores are internal to the system. So how you create a level 0 or context diagram? So you have to first place a single process symbol at the center of the page, and you identify it as process 0. Then you have to surround all the external entities around the process, and you have to use data flows to connect these external entities to the central process. So this is the format. So it depends how many external entities will be there in that particular system. So it should surround, it can be repeated, you can balance it. Okay, the rule in DFD also, there must be balancing. So for example, at this part, you will put all the inputs to the system from that entity. And then at this part, you can put also the outputs that all external entities will be receiving from that particular process. So this is an example of the level 0 or context diagram. So here we put 0, so it means this is indicating the name of the system, which is the order purchasing system. Now surrounding it are the external entities. So there are 4. Inventory control department, customer, warehouse, and accounting. We will not count again customer because it is just repeating. So all inputs are represented with all arrowheads pointing to the system. So this is all inputs. Then all outputs are represented with all the data flow, okay, with the heads pointing to the external entities who are receiving the output. Then we have the diagram 0 or the level 1. The diagram 0 or level 1 is the explosion of the context diagram. So it can include up to 9 processes. So in short, it is the detailed processes from the level 0. So it's exploding all inputs, the processes and outputs, and it is showing new lower level of data flows. So major data stores now are visible in level 1 or diagram 0. So each process in level 1 will be numbered with an integer. Now you have to generally start from the upper left-hand corner of the diagram, working towards the lower right-hand corner of your diagram. So this is an example of a level 1 or diagram 0, in which it shows now the detailed processes from that big process. So we have up to 1, 2, 3, 4, 5, 6, 7. So there are 7 processes here. Then each process is connected with the input that can either be coming from the external entity, or it can be coming from a certain process. So here we are trying to show all the complete 4 symbols in the level 1. While the level 2 or the child diagram is more detailed levels. So each process on level 1 or diagram 0 may be exploded to create a more detailed child diagram. So it means that child diagram or level 2 is just optional. If it means that in level 1, you still need to break down a certain process because the process is still big, then you can create a level 2 for that particular process. So the process on level 1 or diagram 0 that is exploded is called parent process, and the diagram that results it is called the child diagram. So level 2 or child diagram is basically based from any of the processes from level 1. So there is a primary rule for creating child diagram. We have to follow the vertical balancing. A child diagram cannot produce output, or it cannot receive input that the parent process does not also produce or receive. So that's all for now. In the next video, we will begin drawing or develop the data flow diagram upon knowing its correct usage of symbols.